This is section 3.4, Graphs of Polynomial Functions, day 2. So today we're going to talk about graphing polynomial functions, and I don't mean graphing them 100% correctly. We're going to do more of sketching today. And what we're going to do to sketch those is we're going to look at x-intercepts, and we're also going to look at multiplicities of x-intercepts, plot those, and we're going to use number of turning points and end behavior to make a rough sketch of what that function is going to look like. So let's look at this first function over here. That f of x equals -2 times x plus 3 squared and x minus 5. So the first thing, I'm going to find my zeros by setting the parentheses equal to 0. So this gives me x plus 3 equals 0, so x equals -3. That happens twice, so that's a double root. And this gives me x equals 5. Then I'm going to look and I'm going to say, okay, the degree of this function is 3, okay, because we have 2 here and 1 here. And then we know that if the degree is 3, you could have 2 turning points. And then I'm going to look at this number out in front, and I know that it's negative, so it's going to have the end behavior looking something like this one. Okay, going back to end behavior, that negative kind of flips that cubic function, so it's going to go downhill. So let's make a rough sketch of what this is going to look like. So first of all, I'm going to graph my intercepts, so -3 and 5. Since -3 is a double root, I know it's going to bounce off, and it's got to come from the top because we know the end behavior on the left is that it's going to infinity. So it's going to come down and it's going to bounce off. And then it's going to come back down through 5. So that's a very rough sketch of what this is going to look like. All right, let's look at the other one. So the second one, we have to find our zeros. So I'm going to set x equals to 0, or 1/4 x rather. X minus 1 equal to 0, and x plus 3 equal to 0. So this one says x equals 0, x equals 1, and x equals -3. This has an even multiplicity because we have the 4 there, so this is an even multiplicity. Because of the 3 here, we have an odd multiplicity. I know my degree is 8 because we have 4, 3, and 1. So that means we could have at most 7 turning points. Okay, remember that's an at most. Doesn't have to have 7 turning points, and it probably won't because of these multiplicities, but we'll just take a look. And I know that it's an even degree, and the leading coefficient is going to be positive, so it's going to look something like this, and especially in terms of end behavior. So let's go and graph our intercepts. So we have 0, 1, and -3. I know it's got to come from down and have some sort of odd multiplicity through -3. It goes through 0 just like normal, so it's going to go up. And then it has an even multiplicity at 1, so I'm going to make it kind of bounce off and then come right back up. So that's a very rough sketch of what this function could look like. So the intermediate value theorem says that if we have a polynomial function, and if we have 2 y values that have opposite signs, there has to be some value in between those that passes the x-axis. So what that basically says is that here we have our graph, and I know I have this point, and I know I have this point. If it's a polynomial function, it's continuous, so it has to at some point cross the x-axis, whether it goes straight, whether it goes down and around, whether it's just going down and back up. You can draw it a million different ways, but no matter what, it's always crossing that x-axis. So you know there is a 0 between those two if you have a positive y and a negative y. So let's show that f of x equals x cubed minus 5x squared plus 3x plus 6 has at least two real zeros between x equals 1 and x equals negative or positive 4. So what I'm going to do to look at this is I'm going to make an xy chart. And I'm plugging in 1, 2, 3, and 4. So if I plug in, so by the way, helpful hint, if you go in your graphing calculator, there's an easier way to do this. So you can just plug in your function and go to the table. If you hit second graph, there's a table, and you can change your settings to where you have a, you can input x values. So when I do that, when I plug in 1, I get 5. When I plug in 2, I get 0. When I get 3, I plug in -3, or I get -3, and 4 gives me 2. We're looking for at least 2 real zeros. Well, luckily, we have one right here. Because y value is 0, that means it's crossing the x-axis, so there's 1. And then we're going to look to use the intermediate value theorem. And what I see is I see that we have a negative y value and a positive y value. So if I were to graph it, if I were to graph those 2 points, we have 3, -3, and 4, 2. We somehow are going to have to cross that x-axis, so we know there's a 0 somewhere between x equals 3 and x equals 4. And the last thing, writing formulas for polynomial functions. If you're given the x-intercepts, it's pretty easy to write a polynomial function from there. So we identify the x-intercepts of the graph to find the factors of the polynomial. So the factors are going to be these parts. And then we're going to determine whether, we're going to examine the behavior of the graph to determine if we have any multiplicities going on. And then write the equation in factored form. Once we have that, we need to find our a value. So very similar to how we did with quadratics, you can find a point. Usually the y-intercept's a very good one to use to determine that a value. So let's look and let's write a formula or an equation for this polynomial. So the first thing, I want to identify my intercepts, and I want to identify any multiplicities. So this one, it looks like the multiplicity is going to be 1. This one's going to have an even multiplicity, and for the sake of ease, I'm going to have that be a multiplicity of 2, just so we have the lowest degree possible. And then this one looks like it just has a regular multiplicity of 1. So I know that one of my zeros is x equals -3. And I want to think backwards to say, okay, what did I set equal to 0 to get that x equals -3? So that leads me to the factor x plus 3. Same thing for x equals 2, that gives us the factor x minus 2. And I'm going to have that squared because it's an even multiplicity. And x equals 3 gives us the factor x minus 3. So right now we're at the function f of x equals some number a times x plus 3 times x minus 2 squared times x minus 3. Now I'm going to pick a point. I like the y-axis, or the y-intercept, that's always fun, to find our a value. So in this case, we have -2 equals a times, and then 0 plus 3 is 3, 0 minus 2 is -2 squared, and then 0 minus 3 is -3. 2 squared is 4 times 3. Oh, I'm thinking the wrong number. These 3's should all be 5s, that's my bad. So I apologize for that. So this should be x equals 5, x minus 5 here, and this should be a 5 here. So sorry about that. So we get negative 2 is equal to 60a. Dividing by 60, we get negative 1/30 for a. So our function, I go in and I take a out, and I plug in my negative 1/30, and here is my final function.